So lenses comes under refraction topic. Under reflection we discuss mirrors. Reflection we discuss mirrors, because reflection we can observe in mirrors, but refraction day-to-day life we normally use lenses for observe refraction, right? What is a lens, right? So a lens is an optical device with curved surfaces that you need to remember, made of glass, plastic or any other transparent material, so they can refract light rays. So lenses commonly used in telescopes and binoculars in daily life, and also it used in microscopes and specs also, right? So those common instruments also need to remember. Binoculars, telescopes and specs, and also microscopes, right? Simple and complex microscope both. Okay, then lenses, there are 4 types. We'll see what are those 4 types. Biconcave, you can see 2 convex, biconvex, first one, sorry, not biconcave but biconvex, right? So 2 surfaces, all 2 surfaces are convex. And plano-convex, plano-convex means one surface is plane, it's straight, and other one is convex. And biconcave, 2 surfaces are concave and also plano-concave, plane surface and straight surface and a concave surface. Okay, so here I think you remember, like in mirrors we mostly discuss about concave mirrors, because it creates lot of images according to the position of the object. It creates lot of images. But in lenses we have to discuss convex lenses, because convex lenses creates images according to the position of the object, it changing, right? But in concave mirrors, concave lenses, they it's not changing, same virtual and also upright image created. So normally people say concave mirrors and convex lenses going together, and also concave lenses equals convex mirrors, right? So you can remember pattern like this. Okay, so but unlike mirrors, so this midpoint we called as optical center, but in mirrors we called as pole. I think you remember this point is called as pole, midpoint, but here it's optical center and it's named as C, right? This C is not center of curvature in lenses, right? That's you need to remember. The midpoint between 2 surfaces of the lenses is called the optical center of the lens. Here you can see 2 spheres meet each other and forming this convex surface, 2 convex surfaces. That's why it says like this, right? Okay, so here we discuss what are the 4 types of lenses and also what is optical center, and also we have to check what is the focal point of the lens, focal point or the focus, so which indicates by capital F. So focal point, how to identify focal point? To get the focal point of convex mirrors, you need to bring parallel light rays, right? Parallel light rays, beam of light rays, then you can see at the other side one point, these all the light rays are meet each other and forming a very bright color dot. Which point, that point we called as focal point of the convex mirror. Right? So always remember, these convex mirrors are convergent lenses. These lenses are convergent lenses because it converging light rays. But concave lenses are divergent lenses because these parallel light rays, they diverge. But convex lenses, they converging light rays. So that's must thing that you need to remember, right? Okay, so then the descriptions, so read that part. Then you have to know and a focal length, I forgot that. Focal length, the distance between optical center to focal point, we called as focal length. This is in mirrors also we learn P to F distance is focal length, right? Okay, so then here also we have basic light rays. 3 basic light rays we have to learn. One is going through the optical center, which is not refracting, it's going same incident ray and refracted ray in same pathway. Then second one is the light rays come parallel to the main axis and it goes through the focal point, right? Focal point of the lens. So after the refraction, refracted ray goes through the focal point, right? And the other one is the light ray comes through the focal point and after the refraction it goes parallel to the main axis. So this is not complex like our mirrors, because mirrors I think 5 basic light rays, but here only 3 basic light rays. So all the images you have to form using these basic light rays, right? Okay, so then you have these images formation, right? So object, where the object located and where the image creating and what are the features. So that thing you need to know. So what I want you to do is, so you need to practice each one of these diagrams by drawing and write the features, right? First one is object between lens and its focal point. Lens and its focal point, here the object. So one light ray draws like this parallel to the main axis and it goes through the focal point, and the other one is goes through the optical center, not refracting. But this side there is no converging of light rays. Then we have to extend these light rays to the same side, and also it creates a upright virtual image. This is not a real image, right? Because it creates same side of the lens, right? So this one we use in normal magnifying lenses, right? Like people using in day-to-day life magnifying glasses, right? So they use this in day-to-day life, like reading newspapers, like we can enlarge letters using this mechanism. So we have to locate the newspaper between F and C of the lens, right? So if you increase the length between newspaper and the lens, you can't see anything because it's not creating virtual enlarged image. Then it goes for real images for the other side, right? I think you understand. So basically practice this. And the second one, when the object is on the focal point, when the object is on the focal point, all the light rays goes into infinity, right? So image formed in infinity, and this image is larger than the object. Image is larger than the object, right? So that thing you need to remember. And then next one, focal length is object is between the focal length and twice the focal length. Focal length and twice the focal length, right? Here is 1, here is 1. For twice the focal length, normally we named it as 2f, right? Here is f dash, but 2f is better. So here the image creates beyond 2f, right? Beyond 2f, and also it is what kind of one? It's a magnified inverted real image, right? Magnified inverted real image beyond 2f. That thing you need to remember. Then fourth one, so you need to draw, right? I am discussing now, but you need to draw all the images, right? So I will check in the next class. So then fourth one, it's equal to the object distance is equal to the twice the focal length. So object plays on 2f, right? 2f. This point is normally in mirrors we call it as C, but here it's named as 2f, right? Not C, because C is on the midpoint of the lens, right? So here what happened is image create exactly 2f, right? Like mirrors also it's create at exactly C. Here also it's created at 2f, right? Same size but upside down or inverted image, and it's a real one, right? But same size, same position. Okay, then the last one, its object distance is greater than the twice the focal length. It's beyond 2f, and the image create between f and 2f, right? So here, right? So what is the features of this is image is diminished, real, and upside down. Diminished means color is faded, right? Faded color one. Real image, but it's inverted. So then you have a table like mirrors also, you have a table like this. So you need to write down this, right? Read and write, always read and write, then you'll get practice for this. So draw the diagrams and draw this table also. Okay, so then concave lenses. In concave lenses, not much to discuss. It's like convex mirrors. So concave lenses, and the last part of this lesson we'll discuss after new video, because it's somewhat longer than the expected one. So one thing before you doing questions from this, so complete these diagrams, practice this twice, and then you will be can ready for the exam. Okay, thank you.